All right, so you're probably pretty familiar with the sine wave, right? That smooth, predictable up and down rhythm. But did you know it has a twin? The cosine wave. And at first glance, they look almost identical, but they're hiding a secret. And understanding that one tiny difference unlocks a whole new level of trigonometry.
I mean, just look at them. It's the exact same beautiful flowing curve. So what gives? If they're identical twins, what's the secret? Why would we have two different names for what looks like the exact same thing? Well, that's the mystery we're going to crack today.
And the answer, you'll see, starts by going right back to the very beginning, to the one fundamental difference that sets these two functions apart. It all boils down to where they come from, the unit circle. As you travel around that circle, the sine function is tracking your height, your y-coordinate. But the cosine function, it's tracking your horizontal position, the x-coordinate. That's it. That is the one single difference.
Now, this has a really direct consequence. At an angle of 0, when you're on the far right of the unit circle, your x-coordinate isn't 0, it's 1. You're at your maximum. And that's why the cosine wave doesn't start at the origin like sine does. Nope, it starts at the top, at its peak value of 1.
So here's the crucial takeaway. If cosine is just tracking a different coordinate on the same journey around the circle, then its graph isn't a new shape at all. It's really just a shifted version of the sine wave. Let's see how this all connects.
In math, we call this a phase shift. The cosine of x is exactly the same as the sine of x plus pi over 2. And remember, when you add to the input of a function, you shift its graph to the left. So you can think of the cosine wave as leading the sine wave. It gets to every point in the pattern a quarter period earlier.
This relationship means that cosine follows the same awesome quarter period structure as sine. Let's trace the 5 key points over one full cycle. It starts at 1, drops down to 0, hits rock bottom at -1, comes back up through 0, and finally returns to 1. See, it's a simple, totally predictable pattern.
So this gives us an incredibly easy pattern to remember. While sine's pattern is 0 max 0 min 0, cosine is just max 0 min 0 max. Seriously, if you can just remember that 5-point sequence, you can sketch a cosine wave instantly. No calculator needed. Okay, so that's the theory. But how does this little pattern actually help us solve real problems? Let's put it to the test.
Here's a classic exam question. What is the value of the cosine of pi? Now, you could try to memorize the whole unit circle, or you could just use our new pattern.
Let's just walk through it. Pi is the halfway point of a full 2 pi period, right? So what happens at the halfway point in our pattern? Let's see. Max, 0, min. It's the minimum. And the minimum value for a basic cosine wave is -1. It's as simple as that. The pattern just gives you the answer.
Now, knowing the pattern is one thing, but avoiding the common traps is what really leads to mastery. And once you do master it, you'll see this concept isn't just for exams. And I mean this literally, powers our world.
So here's the #1 mistake I see students make. Out of pure habit, they start the wave at the origin. But that's sine. You have to fight that muscle memory. Just burn this into your brain. Cosine of 0 is 1. You always start a cosine graph at its maximum.
And getting this right really matters, because this simple phase shift isn't just some abstract math problem. It's one of the most important concepts in all of modern engineering. You know the electrical grid that powers our homes? It uses what's called a 3-phase system. And what that really is 3 cosine waves running at the same time, but each one is shifted by 1/3 of a period from the others. Why do that? Because it's a genius way to guarantee that power is delivered constantly. When one wave is at its 0 point, the other two are still providing plenty of power. It's a beautifully elegant system built entirely on this concept of phase shifts.
So let's bring it all home. Please don't think of cosine as some brand new topic you have to learn from scratch. Every single transformation you've learned for sine, changing the amplitude, the period, the vertical shifts, it all works exactly the same for cosine. The only secret, the only thing you ever need to remember is the starting point.
And that leaves us with a final thought to chew on. If sine and cosine, these two functions that seem so distinct, are actually just shifted versions of each other, well, it makes you wonder, doesn't it? What other mathematical twins are out there, just hiding a simple, elegant secret, waiting for us to find it?